I'll tell you what natural image is. A natural image is essentially a shorthand for an image which has a rich local convariant structure. That's a bit too odd to understand for someone who doesn't know what a convariant structure is. I'll say it in simple terms. A natural image is something you take on your phone or a camera about a natural scenery or something about like a picture of your friend, a picture of a mountain or your cat. It's all natural images. That's what a natural image is. And apart from that, if you want to go into technical details, this is not the video for you. Try going somewhere else. I'll tell you what a retargeted image is. Retargeted image is an image that is being edited. Like a natural image, if it's cropped into a shorter image or if it's edited or stretched out, it becomes a retargeted image. Anything that is modified, like the picture that is modified, becomes a retargeted image. But for someone who is not able to understand between the original one and the retargeted one, it becomes difficult. That bridge is a bit small for someone who hasn't seen the original image. So what we're trying to do in this one, like in our project, is to make an understanding or a classification of what a natural image and a retargeted image is. Apart from that, we also have two other classifications where we say what a screenshot is and what a Dibr image is. First of all, I'll tell you what a Dibr image is. A Dibr image refers to depth image based rendering, wherein we create many images to create a virtual image or like a 3D image of a structure. Like if you want to make a 3D image of a balloon, you create images from different angles so that you can project that 3D part of the balloon into one image. I'll show you with an example of a bee going into a sunflower. In this example, we can see that the bee is moving. What we infer from this is that we made two images, like one on the left, one on the right. We merged it together to make this view of what we see as 3D image. That's what Dibr does. The Dibr images are the ones classified in this one. Both images classified together, merged together to make a 3D image. That's how Dibr works. And in another example, I'll tell you what a natural image and a retargeted image is. In this one, we can see a cycler going up like on a hill. That's a natural image. Someone took a photo of someone riding a bike. And the other two images are retargeted ones. The first one we see just up to the left, to the right of the natural image is cropped. We can see that the size difference. From the size difference, we can see that the first image of the natural image and the retargeted image is different. But the next image towards that one's right is a bit similar to the one in the natural image, making it a little bit more difficult to identify between the natural and the retargeted image. In this project, what we do is identify which one is real. That's the main aim of our project, to identify or classify these into natural, retargeted, and the other section, Dibr and screenshot, which I'll be saying right now. Screenshot. Everyone might be knowing what a screenshot is because all of you take a screenshot of your phone or of your screen all the time. A screenshot is generally a snapshot of your screen taken in real time. Like if you have a picture on your screen and you want to show it to someone else, or like the content of your screen, you take a screenshot of it. That's what a screenshot means. And our aim is to classify, like if you put an image on your screen and take a screenshot of it, we have to classify if it's a real image or a screenshot. That's also one of the aims of this project.
In practice, very few people train an entire convolutional network from scratch because it is relatively rare to have a dataset of sufficient size. Instead, it is common to use a convolutional net pre-trained on a very large dataset. This is what we did. We use the Inception v3 convolutional net. We feed our training images to the model. The images first go through 250 plus layers of the Inception v3 section of our model. The first 45 layers of this model have been set as non-trainable by us, and therefore the weights for these layers are fixed. The later layers have their weights updated through backpropagation during our training. So we are actually fine-tuning the weights of the higher level portion of this pre-trained network according to our dataset. This is motivated by the observation that the earlier features of a convolutional network contain features which are more generic, like edge detectors, that should be useful for many tasks But the later layers are what become specific, and the later layers of a convolutional net become progressively more specific to the details of classes contained in the original dataset. After the inception section, we have two additional densely connected layers having 1024 neurons each, which use the ReLU activation function. Output of the inception V3 section is fed to these two layers, which then use softmax function to give a 0 to 1 prediction score for each of our 4 classes. So telling you a story about how Inception model got its name, it actually comes from the movie Inception, in which at some point of time the actors say we have to go deeper. So the creators of this model actually created a model which had many layers in other layers. So that's kind of going deeper, and that's where Inception gets its name from.
Conclusion of this image classification. Through the duration of this project, we can tested 3 different choice of models. Building of the scratches, wedge and Inception V3. Inception V3 we just explained in our top performance mode 1 and gave us the accuracy value of 98.3%. The reason why we could arrive at such a great result in the probability in the similarly between the ImageNet dataset and our prediction classes. However, there is a scope for future improvement. Thank you for watching this video and hope you understood what we mean.